So this presentation is going to revolve around choosing the correct orientation for your views in a drawing sheet and also dimensioning those drawings. So you have to remember that whenever you're making a set of drawings, you have to look at it as it's a set of instructions that you're giving to somebody in order to duplicate the piece that you have. So the piece that I'm going to be demonstrating on is a puzzle cube piece that we already have 3D printed. So here this is, and you can see as I rotate this around the different sides of it. You can kind of get a sense for the different views. Remember, views of an object, there are 6 normal or regular views: a front, back, left side, right side, top, and bottom. And as far as standard plans go, you always start with a front view. So what is the front view? So the front view is going to be typically the surface that shows the most detail and the most accurate size and shape description of your object. And you also want to take into consideration that you want all that to be visible. So you don't want to be showing more hidden lines than you have to. So if I'm looking at this object right here, you can see as I rotate that around, like right here I'm showing a lot of detail. I would argue that that view is not as good of a view as this one. I think this view right here shows the most detail. But you could make the argument, and this one right here really is the exact same image, just a different surface. You could make the argument for this one as well, or this one. But again, I think either this view or this view is your choice with this object. The definite wrong answer is this view or this view. Okay, so we're going to be looking at one of the views where you are seeing the largest dimension, and typically you're setting up a plan sheet in landscape form. So when you have a sheet in landscape, you want the largest dimension to be showing the width, so from left to right. You also want to take a look at then when you're orienting this, how it would naturally be able to support itself. So you can see the way that I'm holding it right now, if I would set this down on the table, you can see that it will not fall over this way. Where if I stand it up on end, it won't support itself. So besides the fact that this way right here is going to have the largest dimension vertically instead of horizontally, this also is not a way where it's going to naturally support itself. The only reason that you would orient it this way on your drawing sheet is if this is like the only way that it was assembled into whatever it's a part of. So if this is a part where this is always its orientation, then you could consider orienting it this way for your front view. But otherwise, you want to go with the idea of it's going to have the largest dimension horizontally or from left to right on the page, and it's also going to be able to support itself this way. So now we're going to jump into OnShape and taking this 3D model and making a drawing sheet out of it. Okay, so now here we are in OnShape, and you can see that I already have this object drawn. So this is the same puzzle piece. Of course, I made it red instead of black like I have the 3D print. But you can see as I rotate this around, this is the same piece that I was just holding in my hand. So I made a 3D model duplicate of this. And what I want to do next is I want to create a drawing sheet that is going to be able to be given to somebody to be able to duplicate this. So I'm going to be making a set of plans or instructions to do that with. So here you can see I have a drawing sheet already started, and I can tell you that right now this is not what you actually want. So I'm going to delete these guys out of here. And I'm going to come up here to Insert View, and I'm going to choose that part. And I can just click this into place to start. So once I have that clicked into place, I hit escape to get out of there, and now I want to orient this. So this right here actually looks like the right front view, but it's not oriented the right way. So I'm going to double click on this front view, and I can come over here and I can choose different surfaces. Now it turns out that this actually is the front view in OnShape, but if it's not, don't hesitate to put right view or left view or back view. Whichever one makes the most sense to actually be your front view is the one that you want to show. Okay, top view is definitely not right in my case. So as I'm looking through here, I do believe that the one that says front in this case is actually the best front view. However, this is not the way I want it oriented. Like I said, I want this to be positioned in such a way that it looks like it would support itself if it were setting down by itself. So it shouldn't appear as though it's going to fall over. And I also, unless this is not how it's always oriented, I would also prefer to have the largest dimension being shown from left to right as a width. So in order to change that, you can come up here to rotation angle, and I'm going to, I guess I want to rotate it clockwise. So I'm going to rotate it clockwise 90 degrees, and that is actually what I want it to look like. So I'm going to hit the green check mark. So another thing that I want to do here is I want to show hidden lines. So I just slid this down to the bottom of the page because sometimes the menu disappears when I do this. But if you right click on your view, you should be able to scroll up here and choose Show Hidden Lines. And that should put any hidden lines that are necessary in there. So now that is the front view that I want. It's oriented the right way. I have hidden lines in. Now I'm going to come up here and I'm going to choose Projected View. And I'm going to project another view from the front. So I just clicked on the front view. I'm going to come up and I'm going to place a top view. And then I'm going to click on the front view again, and I'm going to come over and place a right side view. And then I'm going to do one more view. I'm going to click on the front view again, and now I'm going to pull up here diagonal to it, and I'm going to place the isometric. Now your isometric view, you actually do not want that to show hidden lines. You can still see that I'm in projected view mode, so I'm going to hit the escape button. And I'm going to double click now on the isometric view. And I'm going to, first of all, change the scale because, as we've talked about before, the isometric view shouldn't be what dominates the page. So I'm going to check mark that. And now I'm going to slide this down so I can see the whole menu. I'm going to right click on the isometric view. I'm going to do two things. One, I'm going to hide the hidden lines. And then I'm going to come and right click on it again, and I'm going to also show the shaded view. The reason that we do this with the isometric view is the isometric view's purpose is just to show you like the overall look of the object, but also it's there to kind of dress things up and look nice. It's not the most important thing as far as what's on your plan sheet. The most important thing on your plan sheets is your views and the dimensions that accompany them. So I'm going to just move this into the position that I want. So that looks pretty good. I'm going to also do a little bit of moving on this front view here. I like it right about there. And you can see that the top view and the right side view kind of move along with it. This is considered the parent view since we projected these other views off of it. And even though this is the parent view of the isometric isn't tied to it like the other projected views are. So now that we have all of our views in place, we have hidden lines in our front, right side, and top views. We have our isometric view the way we want it. Now it's time to start dimensioning. So when you start dimensioning, you want to be looking at this from you have three sets of dimensions. You have width dimensions, you have height dimensions, and you have depth dimensions, or X, Y, Z. And each of these views shows two of those three dimensions. So on the front, you have the width from left to right, and you have the height from top to bottom. If you move to the top view, you have the width from left to right, and that is the exact same width as in the front view. But then when you're looking at the top from top to bottom here, this is actually now showing depth, because remember, when you go from one view to another, each time you change a view, you're rotating your object 90 degrees. So now if we come back down and over to the right side view, here we are showing the height from top to bottom, but then we are showing the depth from left to right. So what that means is you have to think about when you're dimensioning that you are now dimensioning, let's just say we're going to start with the height. So if I want to dimension the height of this puzzle cube, I have the front view and the right side view that show me those heights. So I'm going to come up here and I'm going to grab the dimension button, and I'm going to come down here, and remember, when you're dimensioning, you want to make sure that you give enough information, but you also don't want to give too much. So you don't want to just start clicking every single dimension. In the case of this puzzle cube, it can be a little bit confusing because all of the dimension numbers end up being one of three choices. So you're going to see some things that are duplicates, but they're not actually redundant measurements, because there are lots of things on here where if I measure them, it's going to say 0.75. There's quite a few that say 1.5, and there's a couple that say 2.25. So you want to make sure that you are keeping straight what it is you're dimensioning. So I'm going to start with the height. So if I'm looking at heights, I have one right here from this point to this point, and if I click on it, that's going to be a 0.75 or 3/4 of an inch dimension. And then I also have one that would be the overall height. So from this point down to this one, and if I click those 2 points, it's going to tell me 1.5, but I could also put that over here from this point to this point, which is what I'm going to do right now. When possible, I like to spread out the dimensions between different views. What you're going for here at all times when you're dimensioning is you are going for maximum readability. You want to make sure that whoever you hand this to, it's as easy as possible for them to understand what it is they're looking at. So when they look at this, you don't want them to have redundant information. What that means is, some people might say, oh, well, I should put another dimension from this point to this one. You're actually not supposed to put a dimension there. The reason being is we have the overall height of 1.5 here, and we know that from this point to this point is 0.75, which means that from this point to this point can only be one thing. We already have enough information to know that from here to here is also 0.75, because 1.5 minus 0.75 equals 0.75. So as far as our heights go for this object, we now have all the information that we need. So let's move on to the depth. The depth is shown in the right side view and also the top view. And one thing that I didn't mention down here, but this is just as good of a spot to illustrate it, is when you're choosing where to dimension something, the best view to dimension it in is always the place that shows that feature the most accurate. Okay, so what that means is this little feature right here, from here to here, if I click on it, it's going to say 0.75. That exact same feature and that exact same 0.75 is shown from this point to this point. But because down here, and I'm just going to click this one in place, so this is a perfectly fine place to put it, except for this is not as good of a visual description of that feature as up here. So right here is actually the better place to put it than this. So I'm going to get rid of this one down here, and to delete a dimension, you just click on it with the cursor and then hit the delete key. So this is the right place to put that. Down here is an okay place, but not as good. So I'm going to choose dimension again. And now we also have an overall depth to show, which I could show up here, and I could do that this way. Click here and drag it out beyond that 0.75, and there is nothing wrong with showing it right here. Again, however, I like to spread my dimensions out, and if I'm going to have a right side view, I'm going to make sure that I have some dimensions on it. So this 1.5 right here makes a lot of sense. All right, so now with this 0.75 and this 1.5, I now have the depth fully dimensioned. So the last thing to dimension then is going to be the width. So there's a couple different ways you can do the width. One, we always need to show the overall. So if I click from here to here, that's going to give me 0.25. That is the same 2.25 as from here to here. You do not and should not have both of these. You should have one of them. Notice that all my dimensions are in between the views as well. Whenever possible, you always want to keep the dimensions in between views. You don't want to do that if it means that things start getting crossed up and cluttered. Then you can move things to the outside, but if you can help it, you want to avoid having dimensions on the outsides of the views. So I'm going to get rid of one of these two here, and it doesn't matter which one. You can keep either one of them. And I'm actually going to get rid of both of them to start, because I like to start with the smaller dimensions first and then place the larger ones outside of them. So I'm going to come in here and I'm going to place a dimension from here to here. And that little purple line that comes up, that's just showing you where it would be aligned with other dimensions. So you can see over here, this dimension is on that purple line, and it's a good idea to keep them aligned. It just keeps the drawing neater. So I'm going to come up here and place this 1.5. And then I'm going to choose one of these two places to put the 2.25. So this right here would be a completely finished drawing sheet for this puzzle cube piece. All of the dimensions are correct. This is not the only way you can dimension this and still be correct though. So for instance, if I wanted to do something a little bit different with the widths, I have this 1.5 which describes this feature right here. I have this 1.5 which describes this feature, and using all of the object lines and the shape of this, you can fully determine exactly where everything is on all of the views here. However, if you chose to, instead of this 1.5, we could delete that, and instead of that, we could put a 0.75 right here. This would accomplish the same thing, because just like 2.25 minus 1.5 equals 0.75, 2.25 minus 0.75 equals 1.5. And you can do the exact same type of switch right down here in this view. What you don't want to do is have 1.5 here and 0.75 here, because now if I do this, I suddenly have redundant information. Okay, so I'm going to get rid of this one. But what we have right here is one of the correct answers for a finished drawing sheet for this puzzle cube.